Organiser is a demonstration web app for the Open University module TT284. This tutorial explores how the code works. The first question that we need to ask is the concept feasible and can it be coded? You need to know what can and cannot be done with HTML5, CSS3 and JavaScript. See the video in my channel and code demonstrations of each of the technologies we are using. When you've established that it is feasible and that it is possible to code it, you need to establish what data items are needed for this to work. This is our first priority before we do any further code development. Think about the data items you need and plan in detail before you start thinking about more detailed code. I am Peter Thompson. Getting the analysis of the data requirements right is one of the most important first steps in development. People are the users of the system, and each person will have a username, a password, an email address, and a number of preferences, such as a name to display for the app, a time to start the app in the morning, a time to close it down at night, and there could be other preferences such as color, size of fonts, and so on. The whole of this app is based around the recording of user activities. So each time that we click on an activity, we're recording when that activity started. And we can record more than once, and then it's updated. So each of these activities is specific to a particular user. It identifies the username that it belongs to. This could be done by the ID of that user in the person table, but to make the database much more readable, we're going to use the username here. Each activity has a description to be displayed on the screen. So here's the description, check the blood pressure. Here's the description, record when I have a drink. Each activity has a time at which it should be displayed so that we can set an activity to be displayed at specific times, a time when it should then be removed or hidden. It can have a level of importance, and we can use this to make the more important activities stand out or to vibrate the device if an important activity has been missed. And each activity has a display order on the screen. So we see here, check blood pressure comes before record when I have a drink, comes before record when I have a meal. So there's an order to them. Now when we record an activity, each record of a recorded activity has the username that identifies who created it. This could be just the database ID of that username in the people table, but we're going to use the username again to make it more readable. The description of the activity. This is in case the user edits a description. We want to retain the description at the time it was recorded. The activity date and time when the button was clicked. So here is the date and time that will be recorded in the database. And we want to link this to the activity, so we can use the database ID of the activity in the table of user activities. Our data requirements are then matched by the structure of the table. So we will have a table which we can identify as people, and it will have columns that match each of the data items for this record. So we can see here that we're creating a table people that has a username that will be the text primary key not null. This is what we will use to index the people table. A hash pass, text unique, email also text. The wake time and sleep time are both text. We will process them later, but we will handle them as text. And the preferences at name will also be a string of text. For our user activities, we're going to create a table called user activities. The username is again going to be the key that we use. So this must be present, text, not null. Each activity must have a description, activity description. So again, text, not null. It has a time from which it should be shown and a time after which it should be hidden. A measure of its importance, again text, and a display order. Now this one is real. This means it's going to be a real number because we will be using that to sort the data into order when we extract it from the database. So we need to process that data item as a real number, so we must store it as a real number. And again, each record of activities, we're going to call the table recorded activities. Again, each recorded activity is identified by the username, who it belongs to, so text and not null. We want to know what we've recorded, so the activity description is going to be text and not null. The activity date time, again, we're going to record this as text and process it as a date time within our scripts. The activity ID, we're also storing it as text, not null. We can match our data requirements that we've just discussed to the script that sets up the database. We've given our database a name, Organiser.SQLite. We've created a handle to this database. So now we have an empty database. We use SQL statements to create each table if it doesn't already exist. And these match the earlier discussion. And then we execute this statement or die with a message to say that creating the table failed. So we're creating the table people, we're creating the table user activities, we're creating the table recorded activities, and the columns for each of these tables matches our previous discussion. The database has been created, but at this point it is empty. This script is then creating our two sample users, creating a hash of the password. We're not storing this password directly into the database. We're creating a hash with salt using the built-in PHP function. And then we are creating an SQL statement to insert or replace into people the values for each of the columns. We're using a prepared statement to insert the hash of the password. This is the placeholder in the SQL. And here is where we bind that to our query, which we then execute. We're not inserting an email, we're simply inserting a reminder, wake time and sleep time, and the name of this particular user's app. In a similar way, we're inserting the activities that will be used by these two users. So first of all, we have the activities for Able Apple. And then if I scroll down, we have the activities for Peter 21. We're not inserting any recorded activities to start with, as these can be simply created by clicking on the app. So when you've got this set up and running, clicking on the app will create activities in the database. So our data insertion for our sample users matches the data requirements that we discussed earlier, and this is the database ready to run. Part 6, Organiser.php, is the file that we run to launch this app. It's also the file that sets out the main structure of the app within the browser. Within the body, we have the button with the ID of My Menu, and by default it displays My Activities and Show Menu. This is the button here, but once someone has logged in, then the text is replaced by the text that they have chosen as a description of their app. We then have the menu, and this menu matches the exercises that we saw earlier on creating responsive menus. Each of the options is a button. We've given it a class, and they all have the same class. On click, they call a JavaScript function. It supplies that function with a value that indicates what's being requested. We can see the responsive design of the menus by making the web page wider. And as we saw in the exercises on creating responsive menus, this is controlled by CSS from the style sheet. We have a div with the ID myTime, and the default is statement time is displayed here. As soon as the app is run, this div content is replaced by the current time. So this div is now occupied by the day, month, date, and time. If no user is logged in, this text and this form is displayed, which allows a user to log in or to create a new account. If we log out again, this text should be displayed. So here is the text, Day Organiser, and the form. And followed by, if I scroll down, the form to create a new account. I log back in, this form disappears, and below it we have division with the ID of main content. At the moment that is empty, but as soon as a user logs in, that division will be populated by the activities display. And at the moment it's displaying 2 activities to record, and it's still displaying the information that it displayed before I logged out. Below that is the Where Am I button, and that is part of this app at all times. Here is Where Am I? If we click on this button, it calls the Where Am I function, which is the same as we saw in our demonstration of adding a map. So a map on a web page, here is the code, here is the JavaScript that we need for the map. We've got the div where the map will be drawn, the script that initiates the map, but this will then be overdrawn by the map at the user's location. A button to hide the map, which will only be displayed when the map is being displayed. The button to log out, which is here, a div that reports the state of information, a div that is used to report whether information has been saved or not, a div to contain admin content, a script that is used to display the charts, and a div that contains the chart. When a user logs into a standard web application on the server may use cookies, which are small files of data that it sends to the browser, to record that the user is logged in and then to check that the user is logged in for the next page request. The server may also use other special cookies known as session cookies to keep track of transactions. In our demonstration app, the user is going to log into the app in the browser, and then the app will log into the server when it's available. This is not the same as a standard web application. This app is designed to keep the user logged into the app in the browser, even if the browser is closed and the mobile device or computer switched off. When the device is turned back on and the browser launched, the user is still logged in. Only selecting the Log Out button logs the user out and requires a username and password to be entered. In this demonstration, the password is stored as plain text within the browser. In a production version, this password would need to be encrypted. Now, if we look at the form that's used for the login, the action is to submit back to itself, and in this example, it simply reloads the page. The server does nothing at this point. On submit, it calls the JavaScript function save to store and passes form login. We're now looking at part 6 appscript.js at the function save to store. This illustrates two slightly different methods of displaying the code that does the same thing as getting the element username from the form. We're getting the password and the username from the form, and then we're saving these both to local storage so that we can extract them at a later date. That's all this function does. The form has caused the page to reload, and we now look at the function that runs when the document is fully loaded. Every time the browser is fully loaded, it will call this function, and we are interested in getUsername. The function getUsername loads the password from local storage, loads the username from local storage. Remember that this would not be in clear text in a working app. If the password cannot be found, then the login page is displayed. But if the password is found, then it attempts to log into the server with the JavaScript function login. The function login now makes an Ajax call to the server, sending username, password, and date today. So it's getting the password from local storage again, username from local storage, the date today using moment, which will give the current date and time formatted as year, month, and day. It's posting this information to welcomeactivities.php. It's passing the username, the password, the date today. If the information returned states password does not match, then the login form is displayed again. Otherwise, the server has accepted the username and password. We display a welcome message to that username, and we receive data back from the server, and that data we're going to put into main content. We're also going to save to local storage the data that we are putting into main content. In the app, loading the app calls JavaScript get username. If the user is logged into the app, get username calls login, and login posts data to the server welcome activities.php. Welcome activities.php is the file we've now displayed here. It opens our database, validates form data, sets our variable user password to be the data we've received from our post, and requires check password.php. Check password selects the hash pass from the table people, where the username is equal to, and we're using a placeholder here for username. We're preparing the statement and binding the value username to the value that we have received from the user. We're then executing that statement. Our hashed password is from the database row under the column hash pass. We're then verifying that the user password matches the hashed password. If they match, we set our variable to true. If they don't match, we set it to false, and echo password does not match back to the browser, back to the app. Back in welcome activities.php, we're selecting each activity from activities that have been recorded for the date today. Again, we're using prepared parameters and binding user and date today to the values sent by the app. Executing our statement and then extracting each row of recorded activities from the database. Then we extract the details for this user from the user activities table, binding the username to the value in a prepared statement and collecting the results. As we go through each row in the results, we're checking to see if this item has been recorded as an activity today, and modifying the code for that item to show the tick and the time at which that was recorded. We're creating the activity button, and we're also adding data as an attribute to this div. So we've got data active ID, data show time, data hide time, data importance, data clicked, data description. So each aspect of that activity button is also included as a data item in the attribute. Next, we select the user preferences that are part of the table people, again using our username, binding it with a prepared parameter, and executing the statement. We're returning a div with an ID of user data to the app, and again we're including data attributes within this div to pass these items back to the JavaScript in the app. The display of activities in the app is controlled by JavaScript in Part 6 appscript.js, and the display is checked every minute. As soon as the page is fully loaded, $function calls the function setInterval. The function checkMinute reads data from the dataset in div userData that was sent from the server. It then uses the library moment to create variables that represent these specific times of day. It then iterates through each of the activity div in main content. It reads data from the dataset in that div for the time at which that activity should be displayed and when it should be hidden. It then uses the library moment to create variables that represent these specific times of day. Then checks if the current time is between these two times using momentIsBetween, when it should display the activity. If the importance is high and the activity hasn't yet been clicked, then the device is set to vibrate and the class is changed to add a warning to the activity display. If the current time isn't between the display times for that activity, then that activity is hidden. When an activity is clicked, each activity button includes the code onClick equals activity clicked and passes code to identify the button. The JavaScript function activityClicked activity ID reads the dataset for this element to get the description and ID. It then adds a tick, a date and time, and writes this back into the div for the activity that has been clicked. It then saves this data within the browser in case the server is not available. It then calls the function sendAjax to see if data can be sent back to the server. The JavaScript function sendAjax first checks local storage to see if any activity data is waiting to be sent. If there is none, it returns without doing anything. If there is data to be sent to the server, it reads the username and password from local storage. Do note that this is in clear text for demonstration purposes only. The sendAjax function now posts to recordActivity.php, sending the username, password, and the list of recorded activities. The status is updated on the app screen. If the server confirms that it accepts this message, then the local storage of the recorded activities is emptied. Admin options such as updating and editing the activity list. All the admin options are standard interactions between client and server, except that we are using Ajax to request the appropriate form from the server. Because we're using Ajax and not refreshing the web page, the activity buttons remain undisturbed. If the server is not available, then the admin functions cannot be updated, but activities can still be recorded and their actions stored. The menu button calls the JavaScript function sendAjaxAdmin and passes action and form ID. The function sendAjaxAdmin receives action and form ID, reads the username and password from local storage, and if the ID of a form is supplied, will serialize the data from the form. This is all sent to admin.php on the server. Admin.php on the server again checks the username and password, and if these match, provides a form for that admin option, validates any data that has been sent, and if the data is valid, will store it in the database. If the data sent is not valid, then admin.php inserts that data back into the form and sends it back to the app. On the app, send Ajax admin action form ID now displays that form in the div with the ID admin content. The user fills in the form, and when filled in and submitted, again uses the JavaScript function send Ajax admin to send the form data back to the server.